Hi everyone. Today I am going to solve number of Subarray of size k and average, and this is a medium level problem. Let's start with that problem. We can just get the hint also from this. Here we have option, hint, company, and topic where this question was asked. So yeah. So in this problem we can say given an array of integer and two integers k and the threshold of return. The number of Subarray of size k and average greater than or equal to threshold. So it will be like we have to be use the k window size, like if they are giving the 3 we have to set the 3 number or 337 I can say. And threshold will be like when we are collecting or we are finding the average, that value should be equal to or greater than equal to this threshold value. I can say if we are getting a 4 or greater than 4, like 5, 6, 7, then that array or that sub array we have to be return the count, like how many count we are getting, like that. So in this input you can see we have a several, like 2, 5, 5. If you are adding 5 plus 5, 10, 10 plus 2, 12. 12 upon 3, 12 upon 3, you are getting the 4, 3, 3 4 are 12. So similarly for this 15, 15 purpose also 5, you are getting, similarly for this you are getting a 6. So you can see our threshold will be a 4, and we are getting the average of that subarray what we are selecting in the window size, in the k3 size. That will be like we have a like condition greater than threshold, or that will be coming. So 4, 5, 6 respectively we are getting. So on this basis we are getting the 3 count. So that's why we are returning the output 3. So all other subarray of size 3 have an average less than 4. If you are selecting the other array size, that will be you are getting the less than 4. So that will be we don't have to be count. We have to be count which we are getting the more than 4 or equal to 4. So this is the problem we have, and we have to be logic, write the code for this, I can say. So it is a Windows sliding problem, I can say. Windows sliding approach we have to be used. Then what we can say, we can start. We have to find out the sum also for the subarray. So I have to create this running subarray. Okay, this one of the variable, and I have to found the count also, like how many subarray count we are getting. So for that purpose, we can create the count variable also. And after that we have to be one pointer which will be keep tracking, like if we are getting the first window size, then we have to be move the second or third one. So we have to minus from this current sum, or like current size, I can say. So that purpose we can also declare one variable l equal to 0. Okay, and now we can approach for this logic. I have to be check each and every indices and the value, and after that we have to be select the size is k equal to 3 here for the first input. So we have to select this range of 1 2 3 3 range. So first I have to apply the for loop also. I equal to 0. I less than how much length we have, array dot length, so that will be length we have. So I can say int, sorry, for int r equal to 0, r less than. Okay, so this is the loop we are applying because we are applying the Windows sliding approach or intuitive. So you can see we have to be go one by one. So that's why we are selecting the array dot length and moving on the row, like counter we are incrementing. After this we have to be check the summation. So what we can do, running some array of I, we have to be take the sum of that sub array. That's why, sorry, r. Okay, after sum we have to be check the this row value is greater than equal to k minus 1. We have to reduce the size. r equal to k minus 1. We have to be apply the take the average or like calculate the average value, I can say. What the sum we are getting, we have to be divide by 3, because the window size what we have, that will be our uh, section which we have to be divided, I can say. The window size will be a 3 here. So it will be containing in the k value. So that's why I am dividing from the k. Then I have to be check if our average value greater than equal to threshold, the threshold value, this one. If we are getting this, then we can increment our counter. Else what we can do, we can, if you're not getting, then we can minimize or like reduce the size of that, like we have to be minus from this current running sum array equal to what we can do. Yeah, that's why I created this help. And how much count we are getting, we just written that. Okay, so this is the approach we are using here. Again, I'm explaining. The approach is very basic, I can say, very understandable. We are creating the one variable for the summation of this each and every element which is containing in the subarray, and the subarray size will be a k. For this problem, it will be a 3. For some other problem, it will be going some other number. So that's why we are using the k for this average purpose also, because how many window size we are selecting, that will be are dividing from this k. And what is the value after getting summation, or I can say dividing with summation of that value, I can say average value. If we are getting the threshold value, which is like for this example we have a 4, the condition is like equal to 4 or greater than equal to 4, so that count we have to be written. So that's why we are using this condition. If we are getting this condition is true, then we have to be increment the count, like how much sub array size we are selected, so we are getting this value. So that's why we are keeping the counter here plus plus. And if not, then normally what we can do, we just uh, using that sum array and incrementing of like decrementing of from this current array, I can say. And time complexity for this problem, I can say, time complexity for this is simply, I can say, we have using this array big O of n and not using any additional data structure. That's why it will be a big O of 1 for the space complexity. Just running the solution, let's check. Yeah, so you can see our code is accepted, test is also passing, just I'm submitting this code. Yeah, code is also submitted. So yeah, that's the very good problem. And hope you got the idea and approach for this problem. Meet you in the next video. Thank you.